Let's first of all introduce our main character, Dave. Dave didn't read the terms and conditions prior to the video. Shame on him. Let's not be too critical of his poor decisions. Each bot will have its own incremental name. Oh, how convenient. Wait a minute, what's this? Dave has friends. Oh dear. Thought they would follow his weird ideologies. Let's get to the fun part, shall we? When we point a gun at one of Dave's best friends and shoot him, a text where the bullet hit will slowly float with the damage amount. I shall also point out the color of the text represents the amount of damage taken or given. Let's hope Dave's best friend isn't colorblind. Oh well. Back to the drawing boards we go.
So for our map, we have 3 Ts. We also have some logic event handlers here, which is the objects to handle events. We have some script references here. So I wonder if we can do this. There we go. So here you notice we have some scripts references, and we have a logic auto which will run one of these scripts on map reload. So let's look at this one first. If we highlight this, we go to outputs. Notice that we have on map spawn, we target logic root. We run the script code of init load. So this will load the initial when we drain into the map. This is very important to get these instances. For the scripts themselves, the first one is logic root, which is game_main. Nothing else apart from that. And it's the same thing with the other one, which will handle the game events script. So now let's look at the most important part, which is the events. The first one is player spawn. Notice event name is a specific event that Counter-Strike uses, which is called player_spawned. What's also very important is that the fetch event data is set to yes. And this will be sent as event_data to the global function. And that's another thing you have to consider when you're using the logic event listener, that these events have to be called globally. You cannot use local instances. For example, if we go to outputs, on event fired, we target player spawn, we run the script code, and we target the event on spawn. Remember, we have this event data, which was given in from the fetch event data attribute here. So we pass this in, and this will contain information from the event. One thing to note is this is a global function. You don't need to add the 2 dots here. For example, this. You don't really need to call that. You can if you wish, but you can just call it as this, as long as you know it's a global function. If you look at this, notice that we changed the function. We have event OnHit. Notice we have the same parameter passed in here. Remember, this is also global. And this one here for bullet damage, event OnBulletHit also passes event data, which holds all the information from this global event. So for bullet impact, this time we are attaching to the event called bullet impact. And for player hurt, we are listening to the event called player_hurt. It's very important that you have this exactly as it is. If it's not, it may not actually fire. Another thing to always remember is to add an output when the event is fired, and always remember to reference itself. So notice target is PLY hurt, and notice this bit here is PLY hurt as well. So remember that. And in terms of the bots, we are adding text dynamically. So as long as we have an info player terrorist, we'll always have it dynamically referencing itself, as you will see from the animation beforehand. And this map is not complex because the features are the most complex part. The cube here is just a node draw, which is hollow of 32 pixels. This is just a wall texture. And to light the environment, we just have a light environment, which simply just goes -90 pitch-wise. Nothing has changed there. That's just gives us just enough lighting for the whole map. So let's start in the actual map. So here we are in the map. Each bot has a dynamic entity, which is a point world text, which will reflect the health that they currently have. In Hammer, I have this bot as named bot_1 and have this bot here named bot_3. But we have to remember when we are doing iteration, it's based on what's the next entity based on the engine, not what we stated. The text here will always go facing forward of the direction of my eyes based on where the bot is and where I am at the current location. I don't have it as a fast refire rate, so the texts are just slowly moving. I could unfreeze the bots, but I decide for this time not to, because it just basically follows by the center of the bots themselves. For example, I take damage to a bot in the leg. We have a little bullet pointer thing you saw there with 25. I notice the health here is now going to yellow. If I aim for the shoulder, it should be 19 or 17 in this case. It's still yellow. I try again. 17, and notice now the bot is now red. Now this can work with multiple bots. If I go here, for example, hit the shoulder twice or 3 times, notice that this is yellow, this is green, and this is red. Each bot is held in memory with their own instances. The one thing to also take note of, that one table takes the entity index of each one, but we have to remember when it comes to the events are not based on the bot entities. It's based on a user ID. You'll soon figure this one out. It took a long while for me to figure this one out, but I finally got there. One thing to take note also is when I shoot something that's not hit, it doesn't show the bullet time. And if we pay attention, it will slowly rise up. And if you aim for the head, notice it goes 70 and then it fades away. Now, this is not confined to just 3 bots, remember. Right, it appeared to have issues with one bot quota, so notice now we have 2 bot quotas. Let's see how we can handle with one. Notice that the timers don't have any instant tracking, so these will come up with errors. So essentially that's all that happens game-wise. Now let's analyze what the script does. So the first script we have is game_main. This will essentially be our main script to make everything work. The first thing we do is we try to import my color chart parser, and if it's not included, we'll throw an error. And then just do a GitHub link to the script. We also include the script of the game text function script, which handles the rotation of the text from the bots. Here we have a global table called bot ID LUT, which stands for lookup table. We also have a global slot, in this case a global variable, which is not assigned to anything, so it's assigned null. Take note that when we work with tables or slots in Squirrel, we need to use the arrow operator. And if we're working with local instances, we have to use the equals. In this case, we have a bot Z offset and a bot X offset to make the text go higher than the center of the bot. This is local confined, so it's only accessible from the top range of the script. I cannot call it from here unless I use 3 variables, which we'll talk about earlier on. We use my color text script here, and then we use some parsing text here to change it to light green and then change it back to normal. This here, I have a function double_cmd which runs lots of parameters of commands to run. So that will run as a client. If this was turned to true, it would execute it as server commands. But you can't use server commands because there's no rcon commands here. So we're just executing it like if the client has typed all of this in. So we have svcheats on, bots don't shoot, zombie, freeze and stop will make the bots unresponsive. MP, human team will mean that we can only join the CT side. Infinite ammo, we ignore the win conditions. We make the bots in T side always respawn on death. We turn off bot chatter, which is ignore grenade video. And we tell the bots to ignore players. And we just turn off the freeze time, which is casual for 5 seconds and competitive for 15 or 10. Then we call a function called initialize bot scopes or init bot scopes. Then after that's called, we just call the parser thing here again, and then we just say it's completed. For the CMD function, we have a parameter which will run the server code if it's true, or if it will just run it as a client if not. Because this is a pseudo array, it doesn't exist. For us to get the volume or the count of it, we need to use var gc. And for us to access each element in this pseudo array, we need to use var gv and then state an element of index here. So that's all that is. So this is non-confined. I can add or remove things here and it will still run as long as there's something here. So here's when it gets interesting. This is where we use lots of Squirrel functionality here. So we have a function here and we also utilize free variables because this here is in the outer scope. When you go into a new function, the new function is one scope higher. So we cannot access this unless we make it into a global variable inside the script. So we can state what variables that are out of scope of the function to bring it into the scope. But please do note, if you use this approach, you cannot edit the variable you pass in. This means that when you access these are read-only access, so you cannot modify these once they're passed in. So here we have lots of local variables. Bots will hold each bot that gets iterated. Bot name will hold the name of the current bot. Num is a counter which tracks how many bots are within the map, which gives each bot an individual number. VScope will hold the bot's scope table. And then LPlayer is local player, which will be assigned to the global slot table of current player. So this is the first stage here. We have brackets, which means this part here gets called first, then it evaluates. So in this case, we assign LPlayer, and then we use the entities find by class name. We reference our next iterator, and then we have find by class name of player. So any person that is real essentially will get picked up here. And we evaluate if LPlayer is not going to be null, or the return value of this function here will not become null. If it hasn't become null, we have a weak reference to the player. This means we iterate once and we store the reference into a slot or a variable. This means we only iterate once instead of multiple times. This can save lots of time, but do note that a weak reference is not a complete reference to that entity that you're referencing. So if this entity here gets destroyed in memory, this means that this thing here will no longer point to that object. And then we break out because we're only estimating for one player in this map. The next stage is we're going to iterate over bots. Notice now that we use cs_bot, which is the class name to identify bots in Counter-Strike. Then we ensure that the bot has a skip scope table assigned to the entity. Then after that's complete, we have a variable which holds the reference to that bot's script. We also use the format, which is provided by Squirrel itself. And this is a wildcard to identify that this here is going to be an integer. This is how each bot will have a bot underscore with a number. We then, because we're working with a scope, use the new slot operator here, which could be also called the arrow slot operator. And then we use entities create by class name. Notice here we're referencing a hammer entity called point world text. This gets assigned to the B scope of, and we call it FT. So then we ensure that this point scope here has its own scope. It's debatable if this should be here. It's up to you if you want to remove it or not. So here we have something called metadata. In this case, these are data that we can change dynamically. Do note that some entities you cannot edit. For example, you cannot create a event listener because it requires some internal data that can be only assigned when the map is baked or compiled. But the good thing about the world text is we can edit these attributes without needing to recompile it. So for here, we have a key value which will be a string. So message is what the text for this pointer will be. Here we have the float, which will be the text size of 10. Color, we have a string. This would be RGB color. This would be default by green. And then we set the angle to -180, so it's facing towards the player. Here we have a different notation of adding a slot to the table. We use brackets, and because we're using brackets, we can use the underscore. And if you notice here, we could also use camel case, which will avoid this. And we could just use fast origin and assign it that way. So this way is the same as this, but using square notation will allow us to add extra characters that we can't use if we're just using normal camel case. Here we have an anonymous function. An anonymous function is a function that is unassigned initially. So we have a slot called centered text origin, which will hold a reference of a function. Notice here we can use three variables. So instead of passing in, for example, a reference to the scope, we can just reference the variable itself, and this means we don't need to iterate over that object. But do take note that if you need to write to this instance of bot, you cannot use this, because remember, these variables here are read only when you pass in through three variables. We have a local scope variable, which will grab the scope of the bot. We have a botSin variable also, which will grab the center of the bot's location. By default, we have a local variable that's set to true initially. If the last origin is not set, we grab the length to the current location, and then we grab the last location noted. We use the length square of the vectors, which is less costly to calculate. And then we reassign change if the length of the two vectors, the current location and the last location noted, are different. This is the detection to change the location of the text. Do take note, we do validate if it's not null, because we can't do a length of a vector if the vector is null. So this will prevent errors. If the bot has changed its location, then what we do is we access its internal attributes of the text here. We change its origin, or where it's located, and then we have three wildcards, which will be a vector. F means that this is going to be a float. So we have the bot center X, and we have an offset. We have the center Y, as well as text offset. This is a calculation based on the text length to make sure it's always center. We'll talk about this later on. And then we have the z-axis offset. So the text will always be center of the bot. And if this is the case, we store the last location to its center location. Then this gets recalled once again, and then we reevaluate up and down, up and down. Here in this case, since this function is assigned, we have a global table, and this is what I was talking about earlier on, about the global the bot's entity index. We have that as a key. Here we have a table assignment. We have a table key code name, and we store its bot's name. We have a reference where we store the weak reference of the bot. That's why when I deleted the bots, it threw errors. Here we have a unique perspective to solving the problem of a user ID for the events. I call this the unique health number. We generate a health value that's way beyond 100 to identify each bot as unique. You'll later find out why we require this. We also have the text offset calculated on first instance. So we grab the bot's length, and then we have a specific number that works with the font size of 10. So if this was not 10, this number here would need to reflect that. This is the number I found to be working with a float value of 10. This will always center the text above the head. Then we call the center command, which will center the text to the bot's current location. We increment the bot counter by 1. Then what we do is reassign the bot's health to the unique number. We then create the logic timer, which will fire a few seconds. I think in this time 2 seconds per second. 2 times per second, sorry. So we have a scope and we have a slot called timer, and we create a logic timer. Here we access the internal attribute, which is called refire time, and we set this float to 0.5. We validate that this scope exists. We then, this is a different approach. We have the bot's entity index stored as a slot, and here's an important part. We have the on timer referencing to text move. That's the text here from the game text func class. And then the important part is to assign this output to the logic timer. We attach the on timer output from logic timer and we assign it to the on timer. Notice that this argument here will be based on the timer scope, so therefore it's important to assign this function to the slot. And then finally, we enable the timer by calling int_fire by handle. We target the timer that we created here. We enable it. We don't have any inputs for this function because input does not require any functions. We have a delay of 1 second, and then we don't need a caller, and we don't need an activator because we don't care who's activated it, and we don't care who has called it. So we can just leave those both null. Before I go to the events script, I want to go over the game text function script. Here we depend on Sammy's already taken's VS library, but specifically we want the VS_math library. If it's not been found, we show to the user on the console that the script is missing. We have a function called textMove. If you go back to the main, notice that this is a function reference right here to the slot. Here we have the t-index. So when it comes to a function, you can use the keyword that's reserved called self. So this would be whatever the caller of the function is. In this case, when self is called, or the function is called, self will essentially be the timer here. So we can sneakily use self to grab the script instance, and we grab its target, which we have assigned from here. So in this case, we have assigned the bot index. This is important because we use this to grab the current index from here. Notice we use a global table here. We access this with the index, we access the ref slot, and then we access the scope, and then we have the bot's text reference here. So now we have an instance scope to the text. That means we now have reference to the location and angle of the text of the current bot. We have another local variable called final vector, which utilizes the vs.getAngle from the VSMath library, and then we access the global slot or variable called current player, remember that from the first part in game main, and we grab its origin, and we grab the text's current object origin. This will do a calculation to give us the angle placement of the player to the text. We then rearrange the angle of the text based on the final vector of x and the final vector of y. Remember, when it comes to angles, it's pitch, yaw, and roll. Do take note that that is x and y in terms of the vector. Then we finally call the bot reference, and then we tell it to recenter the text origin. That's in case the bot is moving, it will recenter based on that. Here we make sure that the color chat and the VSMath library is accessible. We might not actually need this, so I'll double check that. Here we have some local variables that are out of scope from functions, which will hold the RGB values. Here we have a UID bot, which is a global script variable, which is a table, and we also have a UID bullet buffer, which will hold the person who has shot the bullet. Notice now we have a function called getRGB by value. We have default value arguments, which are always called at the last section and not the front. We also utilize some free variables. So remember from last time, because this is local, this is only available from the top scope. For us to use this into our function, we have to bring it onto the scope. So this means that this gets brought into the function scope, and remember it's only read-only access. So here we check that the input is more than the yellow threshold, which is default by 50. Then we show it green. If the user has decided that this threshold is more than 50, they can state it by calling the function, leaving this as 20, and then bringing this to whatever value they want. Here we have some more complex logic, but not too complex. We check if the input is less than equal to the threshold, or if it's more than the threshold, we show it as yellow. If not, we have shown it as red. Remember that this is a ternary operator. Here's the fun part. This is the event OnHit. Remember that this is a global function, so we utilize two of these symbols to reference that this is globally accessed. Yet again, this is an anonymous function because it's not named. It's just holding a pointer to this slot name. Here, we ensure that the slot table, lookup table here, is not empty, and we check that if the bot user ID is not already present within our global table called UID bot. This is where we use the unique health number to identify the bot user ID to the bot. So here we see we can match what the health was, because we have an attribute here called health, and we have an attribute here called DMG health, which is damaged health, which gets called by the function argument here, which is passed in from the event. From here, we do an iteration for each key and value of the bot's lookup table, which is globally accessed. Here, we can check if the bot we want is referenced, remember that each bot has a unique number. So if this unique number here is not matched, we just continue to the next bot. We keep doing that until we've matched. If we have matched the bot with the unique health and it's not present in the table, we assign that to the UID bot, which will hold the user ID to the bot ID. Now this might be confusing, but the reason behind this is we do not know what the user ID for the bot is once they spawn in. So this will hold a reference to the bot user ID, and the K will hold the reference to the global table to reference the bot. So that's what that does. Then we pre-assume the bot's health. We can do this by setting it back to 100, and then we can take away based on the damage health. So the bot will now be back to 100 to take away whatever the damage was. So in this case, we have removed the insanely high value and done it basically we've done it back to base of 100 to take away whatever damage has been taken. Then we break because we don't need to iterate over other bots. We have two local variables, ID and health, which will hold the health of the current bot at that time, and we hold the ID to reference that bot. Here we check if the attacker, which is the user ID of the person who shot the weapon, is a part of the UID bullet buffer table. Therefore, we know that the person has hit the person. We have a variable that is null called hit text, and we have a bullet vector, which is the location vector of where the bullet hit. Here we have two local variables as well, 15 and 0.5, which is the refire rate of the text floating up. And then we have the bullet forward offset, which is how far forward the text is from where the bullet was hit. We use the VS Math module again, or script again. This time we're getting the location of the current player to the bullet vector. So the bullet text will always point towards the user. Here we create a brand new point world text. Yet again, we just do the same internal properties. We set the text to the damage taken. We set the text size to 10, which is by default. We utilize the get GB by value, and that is based on the damage value. So that will be 50, it will be yellow, red will be 30 or 50 below. And if we've done good damage, that would be green, which is beyond 50, I think it is. So from here, we have angles. Remember that we use the format function, which is already provided by Squirrel. And we have float wildcards here, which is %if, and we assign that so that the text will point to the final vector of the person facing the bullet. And another important thing is that we set the text origin, which is the center point where the bullet hit, to that location of the bullet. So yet again, we have format, which is already provided, and we have 3 wildcards, which is floats, and that will be where the bullet was hit. And we have an offset here, because sometimes, depending on the angle of the player, sometimes the text might go into the wall. This will prevent the text from clipping into the wall, so we have an offset. Here we have the timer, which will act as the thing that will rise the text. Here we have the refire rate. We set that to 50 milliseconds, which is actually quite quick. So that'd be half a second floating up. We now use the validate script, which will ensure that the script has been created. We then grab its scope and we have an other anonymous function assigned to onTimer slot. Yet again, we can utilize 3 variables to bring in the scope here, which will save us time. We have a local variable called curpos, which is the current position of the origin. So then we bring the height of that origin up by 0.25 units. And then we reset the origin to that new origin. So that's what makes it rise. we assign the output on timer. We use int_fire to enable the timer. We also have a delay. Half a second after calling this, it will fire because we have a delay of 0.5 seconds. After that, we delete the UDA buffer slot because we don't require it anymore. And in this case, what we do is we change the bot's text above the head based on their current value. And if the bot has died, essentially if the health is less than 1, then we turn off the timer of the bot until they respawn. We're near the end of this. Now we have the onSpawn. If we have the user ID present within the UID table, we then grab the ID reference based on that user ID. We reset the color back to green, which is 100, and then we enable the timer again to allow the text to rotate and reflect health based on color. And then finally, the easiest event, which is OnBulletHit, essentially just has a slot table where we assign the user ID who shot the bullet, and we just assign where the bullet hit as form of a vector. This is close to the vector class, which has a constructor, which is here. So we basically turn 3 variables from the argument passed here, and we just simply turn it into a vector object. A lot to take in, and hopefully this gives you an update intake on how this works. It is complex on how I achieve this logic, but hopefully you have learned lots of ideas from Squirrel and patiently waiting for Counter-Strike 2 to come out until I do much more. So hopefully that won't be long, sometime soon. I might make some more videos, who knows, but this will give you an update on multiple things to take up in Squirrel. So if you haven't realised, I have a Discord. You can go there if you need help, or if you want to show off some things, but don't overspam. So yet again, I do have a Discord in the description. So it's from me, goodbye until next time.